Welcome to Physics Cartoon Camera. Today our topic is magnetic effect of electric current. So before going to this chapter, we would learn that what is the importance of this chapter, why we are learning this magnetic effect of electric current. So what is the basic concept behind this? We will see now. Okay, magnetic effect of electric current, why this title came and how we can able to learn this concept. Before this learning of the concept, what is the main basic concept we are about to learn now? In this topic we are learning about what is magnetic effect of current, magnetic field and field lines, magnetic field due to current carrying conductor, magnetic field due to current through a circular loop, magnetic field due to current in a solenoid, clockwise rule, force on current carrying conductor in a magnetic field, electric motor, electromagnetic induction, electric generator, domestic electric circuits, short circuit and overloading, electric fuse. So these are all the subchapters which involved in this chapter. We will see step by step. So what is magnetic effect of electric current? So what is the basic history behind this? We will see. The term magnetic effect of a current means that an electric current is flowing in a wire produces a magnetic field around it. So what is magnet? Very simple question to all of you. What is magnet? What is magnet? For example, I gave you the bar magnet to the student. What he will do? Just he will play with that. He will play and he will say yes, sometimes attraction, sometimes a repulsion. Okay. Now exactly, sometimes which is repulsing, the repulsion property of an object. The repulsion property of an object is called magnet. Okay, the repulsion property of a magnet is called magnet, not attraction property. Why attraction property is not? Generally earth also attracting all the objects, so confusion will be start. Only magnet can be repulse entire the universe. Other than the magnet, no another object can be repulsed. So the repulsion property of an object called as magnet. Initially magnet was discovered by Magna. Okay, he is a shepherd actually. Basically he is a shepherd. While going to hill station, he identified some of the stones which is attracting to his metal shoe. In this case what happened, he collected all the stones and he keep on playing. He noticed there are sometimes attraction, sometimes a repulsion. While doing this, after some time, what he made it, he contacted Weber. What this Weber did, he taken one of a test tube. Inside of the test tube he placed iron filings randomly. Okay, and he kept a rubber cork over here. Then he taken one of a magnetite, the natural magnet, we can call it as magnetite or lodestone. Okay, while using this magnetite, from one end to another end he keep on rubbing. While he keep on rubs, he noticed all the iron filings are arranged very sequentially. So he noticed due to this rubbing, all iron filings are arranged properly. Later he placed one of a safety pin over here. Then this safety pin also attracted by test tube. So he noticed something like attraction over here. Now next step what he taken? He taken an iron rod. On this iron rod, from one end to another end, he taken a lodestone and is keep on rubbing from one end to another end with only one direction. After some time, this iron rod turns as a permanent magnet. So this procedure we can call it as uni rubbing. Okay, uni rubbing. Second time what he made it, he taken an iron rod and he taken two lodestones. Two stones he can take it, magnetites. From one end to another end, he keep on rubbing. Okay. While he keep on rubs, again this iron rod turns as a permanent magnet. So this process we can call it as by rubbing. Okay. By rubbing procedure he followed. Then next up what he taken an iron rod and there is a copper wire. He placed the iron rod exactly the center of copper wire. And this copper wire is not contacted any part of this iron rod, just freely suspended. Now after some time what happens? Current carrying conductor is giving a magnetic field. Due to that magnetic field, this iron rod turns as again the permanent magnet. Okay, iron rod turns as a permanent magnet due to electrification. This procedure we can call it as electrification. We given electricity, we got magnet. That is the reason our title now, magnetic effect of electric current. Why we are studying magnetic effect of electric current? Due to electricity, magnetism produced in an iron rod. So that is the reason our topic here, magnetic effect of electric current. Hope you understood why we are studying this magnetic effect of electric current. Okay. Now we can go ahead. Now, how that current wire is giving magnetic field? This is one of a question. Why this current wire is giving magnetic field? Take a current wire. Let's say XY is the current wire. We connected to battery terminals. So current is flowing. Current is flowing from one end to another end. What happens? Nearby you place a magnetic compass. If you place a magnetic compass, so automatically this compass needle is fluctuating. Okay. Why this compass needle is fluctuating? We see that the needle is deflected. What does it mean? It means that the electric current through the copper wire has produced a magnetic field. Thus, we can say that electricity and magnetism are linked to each other. Then, what about reverse possibility of electric effect of moving magnets? From the magnets can we get electricity? That is one of a reverse question now. From electricity we got magnetism. What about in reverse case? We need to see what happens. Now, bar magnet we have prepared. Then we can draw that magnetic field lines. How that magnetic field lines will be. So why this magnetic compass needle is fluctuating? What is there inside of the magnetic compass? So magnetic compass having that magnetism. Okay. Now what we did? We take a bar magnet. We placed in iron filings. We can see that only the poles are attracted much than the center part. Poles are highly attracted. Okay. The space surrounding a magnet in which a magnetic force is exerted is called magnetic field. Now, the path traced by a north magnetic pole to move under the influence of magnetic field is called magnetic field lines. So how to draw this magnetic field lines? That we can see now. Let's say take a bar magnet. Okay. Bar magnetic poles are north pole and south pole. Any one of the pole you place magnetic compass. If you place a magnetic compass, there is an arrow mark. Okay. So this arrow mark where it is showing, put a dot mark. Then replace. Again you place one more magnetic compass needle. Again dot point. Okay. Again magnetic compass needle you place. again arrow mark you show it, again dot point. So keep on the dot points, we can able to do this experiment n number of times like this. So north pole to south pole, from the downside again north pole to south pole. Okay, north to south, north to south. So keep on, you can do this experiment north to south. The magnetic field lines are away from the north pole, okay, and towards to south pole, away from north pole and towards to south pole. So this is the way the magnetic field lines which is forming. We can able to identify through magnetic compass needle. Any doubt, audience? You can able to respond it. Any doubts? Feel free to ask a question now. Yes, we can proceed. Yes, there is a question for you. The magnetic field lines produced by a bar magnet, option A, originates from south pole and ends its north pole. Option B, originate from north pole and ends its north pole. Option C, originate from north pole and end at infinitive. Option D, originate from north pole and end its to south pole. So what is the right answer? Right answer is it originates from north and ends to south pole. Next, the magnetic field lines are intersect at right angles, intersect at angles of 45 degrees to each other, do not cross each other at infinitive. Do not cross each other. Now, magnetic field current carrying conductors. How it is, we will see that. Take a wire and connect it to battery terminals. Okay. Then from the battery terminals current is moving. So magnetic compass needle is fluctuating. What happens? Yes. Now the current direction you can see, which is from top to down. Magnetic field direction north south you can observe over here. Now in the second case what happened? We change the polarity of a battery. Here you can see plus minus, here you can see minus plus. So we have changed the polarity of battery. Then current which is moving from down to top, once current direction changes, obviously the magnetic field direction also changed. Okay. Next, what determines the magnetic field generated by a current through a conductor? Does the pattern depends on the shape of conductor? We shall investigate this as an activity. Now what we did? Take a 12 volts battery, a variable resistance, an ammeter, plug key and a long thick copper wire. Insert the thick wire through the center, normal to the plane of rectangular cardboard. Take care of the cardboard is fixed and does not slide up or down. So connect the copper wire vertically between the point X and Y in series with the battery and plug and key. Now sprinkle some of the iron filings uniformly on the cardboard. Keep the variable of the rheostat and fixed position and note the current through the ammeter. Okay. So on the cardboard sheet we placed iron filings we connected to battery terminals. What happens? Current is coming from top to down. Okay. Now we need to identify the magnetic field lines. So on the cardboard sheet, we placed a magnetic compass needle, and magnetic compass needle is keep on fluctuating. So which is not stopping. So we are unable to find out the magnetic field direction while using magnetic compass needle. So what we need to do now? Whenever the current is flowing through a conducting wire, once we placed a magnetic compass needle, the magnetic compass needle, if it stops, yes, we can able to find the direction. But the magnetic compass needle is not stopping. So there is a concentric circles kind of thing, the iron filings are formed. For that, for the direction of magnetic field lines, we need to apply Maxwell right hand thumb rule. As per Maxwell right hand thumb rule, we have to place the thumb finger along to the current direction. Remaining four-fold fingers will give that magnetic field direction. As per the Maxwell right hand thumb rule, thumb finger following current direction, remaining four-fold fingers will give that magnetic field direction. This is the most important. Imagine that in CBSE they'll ask a question, define Maxwell right hand thumb rule. Your answer, imagine that you are holding a current carrying straight conductor in your right hand such that the thumb points towards the direction of the current, then your fingers will wrap around the conductor in the direction of field lines of the magnetic field. Okay. Now there is a question. This is one of a frequently asked question in CBSE. We will see what the question is. A current through the horizontal power line flows east to west direction. What is the direction of magnetic field at a point directly below it and the point directly above it? So how to answer this question? Once you can see the current is flowing from east to west, we have to place the thumb finger along to east to west. So remaining four-fold fingers, the top of the wire, it goes from north to south. Yes, because east, west, north, south. Then the direction of magnetic field from the south to north. The downwards, opposite direction. The topwards, like from this side to this side. So we can see the geographical north, south and south, north. So along to the wire, up and down it will be flows. Hope you understood what is Maxwell right hand thumb rule. Yes, audience, you can able to give me a chart. Yes, you understood or not. Maxwell right hand thumb rule. I guess understood. Any doubt? Any doubt? You can able to reply through chat. Yes, I'll proceed further. Now, current carrying conductor in a loop line. The most important 3 marks question it is. Now the current carrying conductor we bent in a loop. Now what happens? The magnetic field produced by a current carrying straight wire depends inversely on the distance from it. If distance increases, magnetic field will be decreased. If distance decreases, magnetic field will be increased. Similarly, at every point of current carrying circular loop, the concentric circles representing the magnetic field around it would become larger and larger as we move away from the wire. Now, as we move away from the wire, the concentric circles representing magnetic field becomes bigger and bigger. At the center of circular loop, the magnetic field lines are straight. By applying right hand thumb rule, it can be seen that each segment of circular loop produces magnetic field in the same direction, due to which the strength of the magnetic field at the center increases. Now, there is a question based on this. In this diagram, what it refers to? It refers to a circular coil. Fine. Hope until that you understood. And today I'm concluding early. This chapter onwards, again it will be next sub chapters we need to understand. So we'll meet tomorrow, and we are expecting the more number of people has to be joined. Solenoid, then remaining sub chapters will be explained tomorrow at the same time, 10 to 11. Thank you. Jai Hind.